Hello, in this lecture we're going to talk about a problem related to product mix. We're trying to decide how much of a product we should produce, and in this case we have product A and product B, and we're trying to decide how much or if any of each of these products we should produce, what will maximize the revenue in each situation. Data on the left hand side, we've got the product data. We have the selling price for product A, product B. We got the variable cost, product A, product B. That will give us the contribution margin per unit. Remember the contribution margin per unit being the selling price minus the variable costs. And then we got the machine hours for 1 unit. So it takes 0.4 hours for 1 unit product A to be created. It takes 1 hour for product B. Maximum unit sales price, maximum unit sales per month are 650 and 250. So we believe that we could sell 650 of A product and 250 per month of product B. And then we have the added information. Current operating hours per month are 176. And then we're going to run some scenarios. Scenario 1 would be a proposed increase in production operation hours to 352 hours. And then that increase will produce an added fixed costs. So in order to analyze this, first we're going to calculate the contribution margin per machine hour. This is going to be a common type of calculation. Notice that here, if we were just to figure which one should we produce, A or B, product A or B? Well, if we look at the contribution margin, it's clear that A has 135 per unit versus the 108. So as long as we can keep selling those, we would be better off to be producing product A, given everything else being equal. But everything else isn't equal because product A takes longer to produce in terms of machine hours, and therefore it's often useful to figure out what the contribution margin is per the constraint item, which is usually machine hours or like labor hours. All right, so we're gonna calculate the contribution margin per unit. So the contribution margin per unit given in the problem is 135 and 108. Then we're gonna take a look at the machine hours per unit. And that will be the 0.4 and the 1 here. Now I'm going to adjust the settings. I'm going to go here. I'm going to go to the Home tab. We're going to go to the alignment. I'm going to increase the decimals. And we're going to go to the Home tab, font, and underline. And that will give us the contribution margin per machine hour. So we're going to divide this out. I'm going to take the 135 divided by the 0.4 machine hours per unit. And we'll take the same thing here. We're going to say this equals the 108 divided by the 1, which is going to be the 108. I'm going to add some decimals, so I'm going to highlight these two. I'm going to go to the Home tab in the number group and make some decimals there. And so we can see that product A still has a higher contribution margin per machine hour by far now. That has extended the difference than we had here between product A and B and just the contribution margin. Therefore, if we can, as long as we can keep selling product A, we're going to keep on selling product A until we can't sell it anymore. So we have 650 units we believe that we can sell. We're going to maximize those out before we move to product B under this scenario, under this analysis. Also note that this won't always be the case that the contribution margin per unit is higher for product A than B here. It could be lower in some cases based on the machine hours, and that would affect our decision on the product mix as well. So now we're going to calculate the hours it would take or be required to produce the maximum number of units. So we're going to start off with the maximum units per month that we believe that we could sell, and that's given over here. So for product A, we think we could sell 650. For product B, we could sell 250. And then we're going to have the machine hours per unit, and that's going to be the 0.4 and the 1. And once again, I'm going to change the formatting. Now I could format paint these. I'm going to highlight these two up here. We're going to go to the Home tab. We're going to get the paint brush and just format paint that. We're adding the decimals and the underline essentially. So then we're going to have the hours required to produce the maximum units. We're going to multiply that out. I'm going to say this equals the 650 times the 0.4 tab. We're going to say this equals the 650 times the 1 hour. The 250 times the 1 hour. And if we add those up, then we're going to say the 250 plus the 260 plus the 250 is the 510. So we would need total hours of 510. Note we only currently have 176. Therefore, we're going to spend that 176 all producing product A because we think that we can produce that, we can sell 650 units, and we get the highest contribution margin both in total as well as the highest contribution margin per machine hour Therefore, that's where we're going to spend our time given the limited hours. Next proposal will be that we increase the machine hours to the production time to 352 hours, which will change our opinion there. So now we're going to look at the most profitable product mix under the current operations. Okay, so we're going to start off with the hours for each unit. And based on this analysis, we're going to apply the full 176 that we have right now all to product A. So, and that's because of this calculation up here. We have 260 that we could apply there to get to the maximum that we could produce, and we want to produce all of product A before we move to product B. Therefore, nothing for product B. That's all we're going to produce right there at this time. Then we're going to have the machine hours per unit. I would say that equals the machine hours up here, and we're just going to pull that down to 0.4. I'm going to go ahead and underline that. We could just format paint this. So I'm going to go to the Home tab, paintbrush that, format paint this, so that we can see the 0.4. That'll get the units produced. So I'm going to divide that out. This equals to 176 divided by the 0.4, and that'll give us the 440 units. Then we're going to multiply that times the contribution margin per unit. So remember that what the contribution margin per unit is, that's the variable cost per unit less, that's the selling price per unit less the variable cost. That's what we're walking away with after variable costs, not including the fixed costs. And so that's going to equal, in this case, this number here, the 135, which is given in the data up top. I'm going to go ahead and underline that. I'm going to go to the Home tab. We're going to go to the font group and underline that. And then we'll subtract that out, and that'll give us the total contribution margin for the current operation. So I'm going to say this equals the 440 times the 135. And of course, nothing's in B, so the total is just the total plus 0. Because we have no activity in B, because we're only producing A under this scenario. Now, next we're going to look at the second scenario. We have the proposal over here. Proposal number 1 says that we increase production operations to 350. So we obviously have more that we expect that we can sell than we can produce at this point. Why don't we increase the hours that we're putting in and produce more? If we do that, we're also assuming that there's going to be an increase in production requiring added fixed costs of 13,500. So we can reanalyze our product mix based on that. We're going to start off with the hours required to produce the maximum number of units. So remember, we're still working the assumption that we want to produce product A until we can't produce anymore. And we think we could sell, or we can't sell anymore. We think we could sell 650 of them. And we calculated over here, in order to sell 650 takes 0.4 per unit. Therefore, it's going to take us 260 hours to produce the 650 units. And so that's what we're going to have down here. We're going to say that we're going to apply this. I'm going to just say this equals, and say this equals, and actually just point to that, the 260. And therefore, if we're going to have the total hours that we could use being the 352, this is going to be equal to 352 minus the 260. Why? Because we're going to produce as much as A as we can. Then we're going to apply the excess hours, the 92 excess hours, to the units that we can't sell at A, to product B, where we have a less contribution margin and contribution margin per machine hour. So we're going to say this equals this plus this. That's the total that we are producing. That's our total 352 hours that we applied out to product A and product B. Now we're going to have the machine hours per unit, and that's going to equal our familiar 0.4 here. Takes 0.4, and yes, we do need to adjust the formatting and 1. And I'm going to go ahead and format paint again. So I'm going to highlight these two. We want to underline, do the same deal. So I'm going to go to the Home tab, paintbrush, go down here. I'm going to format paint it, adding decimals and underline. So that's going to give us the units produced. Units to produce will equal the 260 divided by the 0.4, and that's going to give us that 650 again. So we're back to that 650. That's the maximum we believe we could sell. The 92 divided by 1, giving us the 92 that we're going to sell in excess of the product A. So then we're going to multiply that times the contribution margin per unit. So I'm going to go ahead and say this equals the contribution margin per unit. Same thing up there. And the contribution margin per unit, remember, that's going to be the sales minus the variable cost. We calculated that here, so we have the number here. Contribution margin per unit, how much we're walking away with after each unit sales after variable cost, but not including fixed costs. And then we have the contribution margin per unit for B way up here. And I'm going to go ahead and underline those. So I'm going to go to the Home tab, paintbrush, and, whoop, not paint, I don't want the paintbrush. We just want to do it the old way, and just add decimals in the numbers and underlines. We're going to underline over here. So there we have that.